Assalamualaikum and good day everyone. So today we are going to continue with the last lecture for this semester, which is lecture 4 of 4 for chapter 9. Which is we are going to continue with subtopic 9.3 application of differentiation in economic and business. Okay, so today we are going to focus on the second learning outcome, which is to compute maximum revenue, minimum cost and maximum profit by using second derivative test. So earlier for the lecture 3, we learned already how to find the revenue, the cost, the profit, and to find out the average and the marginal. So now we want to find the maximum revenue. So usually we want the highest revenue we can, and then the minimum cost, how to minimize the cost, and lastly how to maximize our profit. What is the maximum profit? What is the maximum product? What is the quantities that we have to produce to get maximum profit? Okay, so let's move on. So example 1. So let's see, the demand for the product of a firm varies with the price that the firm charges for the product. So the firm estimated annual total revenue R stated in thousand is a function of the price P stated in RM. So revenue is a function in terms of P. Specifically, R is a function in terms of P, which is equal to negative 50P square plus 500P. Now, determine the price which should be charged in order to maximize total revenue. So, we want the maximum hasil kat sini. What is the maximum value? So, now we want to determine the price to maximize revenue. So, the keyword here is price, but the second question is what is the maximum value itself of annual total revenue. Okay, so for A, we want to determine the price, which is the P. Here, price is P when the revenue is maximized. So, how to find maximize? Maximum point. We relate with maximum point. So, we learn in second subtopic to find the maximum and minimum point. What we need to do? We just have to follow that step. Okay, so what we need to do is to find the value of P when F prime P equal to 0. So we need to differentiate the function, the revenue function, which is F of P, and then equate to 0 and find the value of P. So what is our F? Our F of P is equal to negative 50P squared plus 500P. So to find the derivative F prime P, it will be 2 multiplied by negative 50, which is equal to negative 100. P to the power of 2 minus 1, which is equal to P, plus 500, P to the power of 0, which is 1. So that's why we have 500 only. So now what we need to do, the next step is to equate the F prime P with 0. So negative 100P plus 500 is equal to 0. So P is equal to 5. So we know now that at maximum revenue, P is equal to 5. So we need to put the price as 5. Okay, 5. Okay, so we know P is 5. But we also need to check. So how to check? Okay, so we can use the second derivative test. So we find the second derivative test F double prime P, which is differentiate negative 100P plus 500, we get negative 100. Means that it always less than 0. If it's the second derivative less than 0, means that yes, it is a maximum point. So maximum revenue exists here. So the maximum revenue exists when the price is equal to 5. So total revenue is maximized at P equal to 5. The price which should be charged is 5 ringgit. Okay, so we have to look at the unit back from the questions. Now, for question B, what is the maximum value of annual total revenue? So because we know that the revenue will be maximized at P equal to 5, means that we have to substitute the P equal to 5 into the function of revenue. So f of 5 is equal to negative 500 of 5 square plus 500, negative 50 multiplied by 5 square plus 500 multiplied by 5. So what do we get here? We will have 1250. So so we can conclude that the revenue is RM1250 thousands. So let's just leave it like that. Okay, so the answer will be RM125 in a bracket 1000. Why 1000? This is given in the question, so we just follow the questions unit. Okay, don't forget to put the 1000. If you leave as RM1250 only, so you will get the wrong answer. So let's see example 2. A company manufactures and sells X transistors radios per week. Okay, so this is the unit. So if the weekly cost and price demand equation are C of X equal to 5000 plus 2X, so we have the cost function depend on the X quantity, the units, quantity or units. Okay, and the Px is equal to 10 minus 0.001x, where x is in between 0 and 10,000. So what is P? P is the price demand function. Find the following for each week. So what is the maximum revenue? So the first question they ask for the maximum revenue, means that we need to find the revenue function first. So do we have revenue? We don't have revenue. So we need to find the revenue function. And then the second question is the maximum profit. The production level that will realize the maximum profit, and the price that the company should charge for each radio to realize the maximum profit. So we need to find what is the price. The price means that the P, the price demand function. Okay, so what we need to give. Okay, now let's see for question A. So maximum revenue, to find the maximum revenue, we need to find the revenue function first. So what is the revenue function? So revenue, it should be the price multiplied by the quantity, right? So this is from the first, the second, the third lecture of chapter 9. So we need to multiply the price demand function with the quantity. So the price for each of the quantity multiply with how many quantity we want to buy. We want to sell, okay, the product lah. So x multiplied by px will be x multiplied by 10 minus 0.001x. So the revenue function will be 10x minus 0.001x square. So this is our R of x. Okay, so now we have the revenue function. What we need to do the next step is, yes, to find the value of x when the maximum revenue exists. So to find the value of x when the maximum revenue exists means that we have to find the value of x when r prime x equal to 0. Now find the r prime x. So differentiate. Second step is differentiate r respect to x. So r prime x is equal to 10 x, differentiate we get 10, and then 0.001x squared will be 2 multiplied by 0.001 will be 0.002. X power of 2 minus 1 is x. So this is our r prime x. So the second step, we equate the r prime x with 0. And then here, if you can see that they directly find out what is the r double prime. Why? Because we need to check which value of x that will give you the maximum revenue. So by using the second derivative test, so we can check lah the value of x whether it gives you the maximum point or the minimum point. So now differentiate for the second time, we get negative 0.002. So means that this is always negative. We don't have any x here, so it's not depend on x, so it's always negative. So the maximum revenue really exists. But now we just have to find what is the value of x when the maximum revenue exists. We equate the r prime x with 0. So r prime x equal to 0, so 10 minus 0.002x equal to 0, so x is equal to 5,000. So the revenue exists when the quantity sold is equal to 5,000 units. So we need, in order to get the maximum revenue, we need to sell 5,000 products. Okay, so then the maximum revenue will get. So now what is the maximum revenue? This is not indicating the maximum revenue yet. To find the maximum revenue, what we need to do? Yes, just substitute this value of x into the revenue function. So R of 5,000 is equal to, so substitute 5,000 into 10x minus 0.001 x square is equal to 10 of 5,000 minus 0.001 of 5,000 square, which is equal to RM25,000. So this is our maximum revenue when we sold the 5,000 product. Okay, so this is the hasil. Hasil. It's different from the untung. Okay, now let's see the question B. Okay, the maximum profit, the production level, and the price. Now we want to find the maximum profit and what is the price when we have the maximum profit. Okay, the production level. So what is maximum profit? So maximum profit is revenue minus the cost. This is standard. So we don't have any other formulas. Just pi x is equal to rx minus cx. So our revenue function is equal to 10x minus 0.01x squared. And then minus with the cost. So don't forget to put in the bracket, which is our cost is 5,000 plus 2x. So what we have is, this is negative. So 10 minus 2x is 8x minus 0.001x squared minus 5,000. So this is our profit function. Okay, so now we have the profit function. To find the maximum profit, we need to find the maximum x, the value of x that will give the maximum profit. So what we need to do is to, first we find out already the profit function. Second, we need to find out the derivative of x, the derivative of the profit function. Okay, so what is pi prime x? So differentiate, we get negative 0.002x plus 8. So this is our answer for pi prime x. So we now find out already what is pi prime x. So to check whether the maximum profit exists or not, we just can directly find the second derivative to use it as the test. So second derivative of profit function, we get negative 0.02002, which is it always negative, means that maximum profit for all value of x we found. So the maximum profit exists actually. So now the third step is to find what is the value of x when the maximum profit exists. So we just equate the pi prime x with 0. So negative 0.002x plus 8 is equal to 0. So x is equal to 4,000. So we have the quantity or the product that we need to sell in order to get the maximum profit. Okay, so what is the profit, the maximum profit? So we have the x already. So we just need to substitute the value of x into the profit function to find what is the profit when we sold 4,000 product. So pi of 4,000 is equal to, so we don't have the maximum profit yet. But here they said that the production level that we realize maximum profit is 4,000 units. So in order to get the maximum profit, we need to sell 4,000 units. So this is the production level. So what is the product that we need to sell? This production level means as the product that we need to sold. So 4,000, so the value of X is the quantity, so the product, so this is the production level. And then what is the maximum profit? So the maximum profit, we just have to substitute 4,000 into the profit function. Here we found, which is negative 0.001 multiplied with 4,000 square plus 8 multiplied by 4,000 minus 5,000, which is equal to 11,000. So this is our profit. Okay, and then the last question is the price. So what is the price? So because we want to produce 4,000 units, so what is the price? So the price, we just have to use the price demand function. So Px, so P 4,000 is equal to 10 minus 0.001 of 4,000, which is equal to 6 ringgit. So we need to sold the product 6 ringgit each. Okay, and then we need to sold it as 4,000 product, 4,000 units in order to get the maximum profit, which is 11,000. Okay, so this is like a, let's say we have this business. So we know that the business is related to this type of equations. Okay, we have the cost function, we have the the price demand function. We can find what is the revenue function, and then we also can find what is the profit function. So from here we can find what is the product that we need to sold in order to get the maximum profit. Okay, and then what is the price that we need to sold in order to get the maximum profit. Okay, so we have cost, we have price demand, we have revenue, and then we have the profit function. So the maximum profit of 11,000 per week is realized when we sold 4,000 radios produced weekly, and it's sold by 6 ringgit each. Okay, so everything here is related to profit. So what is the best for our business? The maximum profit or the maximum revenue? Okay, so if we see question A, we have the maximum revenue. We need to sold for 5,000 products, 5,000 radios in order to get the maximum revenue. But to get the maximum profit, we only need to sell by 4,000 units. Okay, so revenue and profit, which one is important? Of course, profit. Revenue is not subtracted by the cost already. Cost yet. Okay, so we might have to sell, we might have to cut many costs if we sell about 5,000. So let's say we try pi of 5,000. So you can try to find what is the profit when you sold 5,000 radios. So the profit might be less than pi of 4,000. Why? Because we only get maximum profit if we sold by 4,000 units. Okay? Because if we sold by 5,000 units, our cost might be higher. That's why it won't give you the maximum profit. Okay? Okay. So this is related to your business and economics. So you have to think in that direction. So let's continue with the next example. Okay, so let's continue with example 3. So given the demand function and the average cost function. So now we have the demand function and average cost function in RM of a spare part are Px equal to 1,000 over square root of x and C bar x equal to 1 plus 2,000 over x. Okay, so now it's not cost but average cost function. So find the number of spare parts that need to be sold to ensure maximum profit. Okay, so we want the maximum profit, means that we have to find the profit function. So the question asks for the number of spare parts, means that the x, the quantity. And then show that at maximum profit, the marginal revenue equals the marginal cost. Marginal revenue equal marginal cost. Okay, now we need to see the maximum profit. Okay, so we know what is the quantity to ensure the maximum profit. So the marginal revenue and the marginal cost, we need to find what is the function of marginal revenue and what is the function of marginal cost, and substitute the value of quantity that we need to sell to ensure the maximum profit. And C, determine the price of a spare part at maximum profit. So this is price, so it depends on the price function. So let's see how to solve for this type of question. So we have C bar, we have P. So the cost, average cost, and the price function. So to find the maximum profit, or to find the number that we need to solve in order to ensure the maximum profit, we need to find the profit function. So what is the profit function? Profit function, pi R C. Pi RC, so pi equal to revenue minus cost. So revenue function, do we have revenue function? No, we only have price demand function. So what is the revenue function? Revenue function is x multiplied with the x is the quantity multiplied with the price demand function. So that's why it's x multiplied by 100 over sec x. So it's equal to, so sec x is actually equal to what? X to the power of 1 over 2, right? So x to the power of 1 over 2, if we apply the rule of indices, we get x to the power of 1 minus 1 over 2. That's why we have 100 of x to the power of 1 over 2. So this is our revenue function. And then to find the profit function, we just substitute what is our revenue minus with cost function. But what is our cost function? We don't have cost, we only have average cost. So cost, because we know cost, average cost is equal to the cost function divided with the quantity. So the cost function is x multiplied with the average cost function. So average cost function 1 plus 2000 over x multiplied by x, which is equal to x plus 2000. So this is our cost function. So now to find the pi, which is the profit function, revenue minus cost. So 100 x power of 1 over 2 minus x plus 2000 in the bracket. So it will be 100 x power of 1 over 2 minus x minus 2000. So this is our profit function. We are not finished yet. We just find out what is our profit function. So to find the number of quantity or the units that we need to solve in order to ensure maximum profit, we need to, yes, the second step to find the derivative of profit function, pi prime. So pi prime is equal to, so differentiate 100x power of 1 over 2, it will be 1 over 2 multiplied 100 is 50 to power of x power of negative 1 over 2. And the differentiate negative x will be negative 1. So we have this function which is equal to 50 over sec x minus 1. Okay, so this is 50 over sec x minus 1. So this is the second step. To find the maximum profit, we need to let the pi prime x equal to 0. So this is the second step, equate to 0, which is after we rearrange, we get that 50 over sec x is equal to 1. So 50 is equal to sec x. So x is equal to 50 square. So it will be 50. Now 50 equal to sec x. So in order to cancel out the sec or eliminate the sec, we need to square both sides. So it will be 2500, the value of x. Okay, now is this really maximize the profit? So we need to check by using the second derivative. So the fourth step is the test. So pi double prime x is equal to, pi double prime x is equal to, differentiate the 50x to the power of negative 1 over 2, we get negative 25x to the power of negative 3 over 2. And then substitute the value of x into the pi double prime. It's not a constant, we have x here. So we need to replace the x with the value of quantity that maximize the profit, which is equal to 2500. So 2500, substitute the value, we get equal to negative 0.002, which is negative number, which is less than 0. So maximum profit for x equal to 2500. Not for all value of x. This one is wrong. So let me correct this. So it should be maximum profit for x equal to 2500 only. Okay, because we are checking for the 2500. So we have the maximum profit when the product is 2500 units. And now this is the number that we need to produce or sold in order to get the maximum profit. So we can do the conclusion here. The number of spare parts that need to be sold to ensure maximum profit are 2500 units. Okay, so this is another name that we can say that this is the production level. Okay, another words or terms that we can use to say about the products that we need to sell, the production level. So for question B, show that at maximum profit, the marginal revenue equal to the marginal cost. So at maximum profit earlier, we know that we need to sell 2500 units, right? So the X should be 2500. So at this level, maximum profit, when we are selling 2500 units, what is the marginal revenue and marginal cost? So to find marginal revenue and marginal cost, we need to differentiate revenue and differentiate cost. Differentiate both. So we get 50x to the power of negative 1 over 2. And then for cost, we get 1. Right? C prime x is equal to 1. Okay, so at maximum profit, x is equal to 2500. Yes, this is what I said earlier. So substitute the value of x into the r prime x. So we get 550 multiplied with 2500 to the power of negative 1 over 2, which is equal to 1 over 50, which is equal to 1. So we get r prime 2500 is equal to 1. And the marginal cost, differential x plus 2000 is equal to 1. Directly, it's equal to 1. Right? So we can say that even though we didn't substitute the value of x into the marginal cost function, it will still get 1, which is r prime. The r, not pi, this is r prime x is equal to cost prime x. The marginal revenue is equal to the marginal cost, which is equal to 1. So we can say that it is the same, equal to. So for question C, determine the price of a spare part at maximum profit. So we know at maximum profit, we are selling x equal to 2500 units. So we are selling 2500 spare parts. So what are the price that we need to give to get the we need to set to get the maximum profit? So we just substitute x equal to 2500 into the price demand function. So we know price function is equal to 100 over set x. So 100 over set 2500, which is equal to 100 divided by 50, which is equal to 2. So the price for the spare part should be RM 2 ringgit lah. You should put RM as a unit. So you will get the correct answer lah, because this is in economics and business. Usually it will relate to RM. But depends on the question. Maybe they said dollar or USD or anything lah. So just follow the questions. Okay, so this is for example 3. So the last example, example 4. So the average cost function. Here they give you the average cost function. So usually we denoted average cost function as what? It will be C bar X. And the demand function, so usually we represent it as PX. In RM of a company that manufactures computer chips, C bar X equal to 100 over X plus 2 and PX equal to 20 minus 0.001 X respectively, where X is the number of computer chips manufactured. So X is the quantity. Find the cost function. So directly we know to find the average cost function, we need to divide by quantity. So to find the cost function back from the average, we need to multiply with the average cost function. Okay, so done for this one. The maximum revenue. So we want to find the maximum revenue. and the number of computer chips so to achieve this. So we want to find the X to get the maximum revenue. So two things here we need to find: the maximum revenue and the number of the computer chips sold to achieve this. So this is the production level to achieve maximum revenue. And the maximum profit. So maximum profit pula. Tadi maximum revenue, now maximum profit. And then the maximum profit if each computer chip sold is tax RM3. How about this one? This tax RM3. So let's see the solution together. Okay. So what is the cost function? As I said earlier, the same as example 3, we know that average cost is equal to cost function divided by X. So cost function, to get the cost function from the average cost function is equal to, we bring X to this side, so X multiplied with average cost function. So cost function is equal to X multiplied by C bar, which is 100 plus 2X. Okay, so this is our cost function done for question A. So for question B, the maximum revenue and the number of computer chips sold to achieve this. So maximum revenue, we need the revenue function lah, as usual. So what is the revenue function? Do we have the revenue function? No, you don't have revenue function. So we need to find what is the revenue function. So because we have the price demand function, so revenue function is equal to X multiplied by the price demand function. So X multiplied by 20 minus 0.001X, which is equal to 20X minus 0.001X squared. So this is revenue. So we are done with the first step. So the second step is to find the maximum revenue. We need to differentiate and equate to 0. So differentiate revenue R prime, we get 20 minus 0.002X. So we have the second step here, the R prime. And then the third step, to find the value of X, we need to equate to 0, or directly we can check first. So whether the maximum revenue exists or not. So R double prime X is equal to negative 0.0002, which is less than 0, which is the maximum revenue exists here. Okay. And then for the fourth step is to find the value of X. So for the third and fourth step, we can actually exchange the step. Which one came first, it's okay. You can do 3 first or 4 first. Okay, it's up to you lah. So the fourth step is to find the value of X by letting R prime X equal to 0. So R prime X is equal to what? 20 minus 0.002X equal to 0. So X is equal to 10,000. Not 1,000, 10,000. Okay, so when we sold the computer chips by 1,000 units, then we will have the maximum revenue. Okay, but the question asks for the maximum revenue. What is the maximum revenue? So we need to substitute the X equal to 10,000 microchips into the revenue function. So the maximum revenue is equal to R of 10,000, which is equal to 20 of 10,000 minus 0.001 of 10,000 squared, which is equal to RM 199,990 ringgit. So this is the revenue when we sold 10,000 at the maximum revenue lah. The maximum revenue that we will get. Okay. So the next question is, the maximum revenue is 199,990 when 10,000 computer chips are sold. So this is the maximum revenue. Here is the maximum revenue. And here is the production level at the maximum revenue. So next question C. The maximum profit. So earlier we find out the maximum revenue. Now we want to find the maximum profit, which is more important than the maximum revenue actually. So for the maximum profit, we need to find the profit function lah. First should be the max profit function, which is profit function equal to revenue function minus cost function. So revenue function equal to 20x minus 0.001x squared. So subtract minus with the cost function we found already in part A, which is equal to 1000 plus 2x. So what we have for the function here, expand negative here, we get negative 0.001x squared plus 18x minus 1000. So this is the profit function. So the second step, it should be, yes, finding the derivative of profit function, which is equal to negative 0.002x plus 18. And then we can directly check whether the maximum profit will exist or not by finding the second derivative. Okay, pi double prime x is equal to negative 0.002. So it's less than 0, always less than 0, the maximum profit exists. So now we can find out what is the unit that we need to solve in order to get the maximum profit. So the fourth step, which is equal to pi prime x equal to 0. So negative 0.002x plus 18 equal to 0. We get the x is equal to 9,000. Okay, so we will get the maximum profit if we sell the microchips at 9,000 units. So at 9,000 units, we will have the maximum profit. If we continue, we might not have the maximum profit. So we get the production level of the maximum profit. So what is the maximum profit? We just substitute the quantity into the maximum into the profit function. So the profit function here, substitute 9,000, we will get negative 0.001 of 9,000 square plus 18 of 9,000 minus 1,000 is equal to RM 80,000. Okay. See, we have the maximum profit here 80,000. But at question B, we actually have revenue at 10,000 unit equal to RM 199,999,990, which is bigger. But remember, this is revenue. Revenue is actually just the cost plus the it's all cost plus with the price that we sell. Sorry, not price. It's like everything that we get after we sold, but we didn't subtract by the cost yet. This profit is revenue minus with the cost already. So untung dengan hasil. Hasil kita might be besar sebab kita tak tolak lagi cost. Kat sini kita ada untung bersih kat sini 80,000. So which one is important? Of course the maximum, right? Because we don't want to be rugi. Kita mungkin dapat maximum revenue, tapi kalau rugi buat apa? Betul tak? So let's continue with question D. So the next question, the maximum profit if each computer chip sold is tax RM3. So apa ini tax RM3? So this is special case tax RM3. So every computer has a tax by RM3. So each quantity will have to deduct by 3 ringgit if you want to sell it. We get the revenue and then we need to subtract by 3 ringgit for each. So we need to find the new profit function. Why? The profit function has a additional cost, which is the tax. We can call it as cost lah, additional cost. So it should be included in the cost function. But we don't have to start from the earlier, change the cost function and then find the profit function by subtracting revenue from the cost. The new cost function tak payah. So we just have to find out what is our new profit function. The new one by using the old profit function and subtract by 3x. Why 3x? Because every unit, each computer chip, so every quantity, so we need to multiply. How many quantity we want to sell? Like that lah. So that's why the tax function here is 3x. Not only 3 but 3x because each of the computer chips. So what is our pi function, the profit function? We have negative 0.001x squared plus 18x minus 1000 and minus 3x. So it will be minus 1000 yang tertinggal, minus 1000. So minus 1000 here. Okay, so it will be negative 0.001x squared plus 15x minus 1000 is our new profit function. So in order to get the maximum profit, we need to do the same step as question C lah, right? So we need to find the pi prime x, which is equal to differentiate. So first step, we have the new profit function. Second step, we have to find the pi prime to get the value of x, because we need to equate to 0. So differentiate negative 0.01x squared, we get negative 0.002x. Differentiate 15x, we get plus 15. And then we can directly check whether the maximum profit exists or not by differentiating second derivative. So pi double prime x is equal to negative 0.002, which is less than 0, which is the maximum profit exists. It still exists, even though we have a new profit function. And now we just have to find what is the number of computer chip need to be sold. So we let the pi prime x with 0, which is negative 0.002x plus 15 equal to 0, to find the x, the quantity that we need to solve, which is x equal to 7,500. So the new units that we need to solve in order to get maximum profit is equal to 7,500. But this is not the final one. What we need to do is to find the maximum profit. So we just have to substitute the x into the new profit function. Okay, now to find the maximum profit, we need to substitute 7,500 into the pi function. So what is our pi function? So pi function, the new pi function, pi of 7,500 is equal to negative 0.001 of 7,500 square plus 15 of 7,500 minus 1,000. Okay, so you can calculate the value here by using your calculator. If I'm correct, it will be RM46,250 ringgit. You can check whether it's correct or not. Okay, so now we have the maximum profit. So if we have this tax, actually we are having lesser profit, right? Because it's only 46,000 compared to the maximum profit if we don't have the tax for each of the item. Okay, so this tax is important now. So you have to introduce this tax into the pi function and then find the maximum profit after you find the new profit function. Okay, so that's all for this semester. So we are finished with chapter 9. Okay, so hopefully you guys can do your notes for chapter 8 and chapter 9. Everything is related to differentiation, and do your best, because this chapter 9 is actually easier if you know how to differentiate. That's why chapter 8 is important. Okay, so that's all for today. Thank you. Please continue with the tutorial questions. Okay, so I will do some trial for you guys, so that you will be prepared with the examination. Okay, so thank you. Bye.